Remainder and factor theorems. What is the remainder theorem? The remainder theorem states when a polynomial, written as f at x, is divided by a factor, written as x minus a, the remainder is equal to the function at a. If the remainder is 0, then x minus a is a factor of the polynomial. This theorem is very useful for us as we further look at how to factor polynomials. Let's take a closer look with this example. Determine the remainder when x to the exponent 3 plus 7x squared plus 2x minus 5 is divided by x plus 7. First of all, step number 1, rewrite the expression as a function. To do that, we're going to add f at x at the beginning equals x to the exponent 3 plus 7x to the exponent 2 plus 2x minus 5. Now, let's review some theory. We know that f at x is equal to one factor, x plus 7, times the quotient plus the remainder. We proved that in our previous slideshow. To be a factor, x plus 7 must be equal to 0. Or written another way, it means x is equal to negative 7, moving the positive 7 to the right-hand side. Number 3, substitute negative 7 into the equation then to determine if it is in fact a factor. So we will take f at negative 7 equal to negative 7 cubed plus 7 times negative 7 squared plus 2 times negative 7 minus 5. When we work that out, we will get the answer negative 19. So that shows us that the function at negative 7 is equal to negative 19, since when we substituted in negative 7 into the function and it did not equal 0, negative 7 is not a factor. In our previous example, we knew what the number we were testing was. But what happens when you don't know one of the factors? For example, if you were given x cubed minus 5x squared minus 2x plus 24, what would the factors be? Now here is a review of the theory. Factors of f at x will be of the form x minus a, since the leading coefficient of f at x is equal to 1. Since a must divide into a constant term, the possible values of a are therefore the factors of the given number 24. So let's look at the steps. Number 1, determine the factors of the constant term 24. If we look at them all, we know it's plus or minus 1, plus or minus 2, plus or minus 3, etc., until we get to plus or minus 24. Start by trying the first value, x is equal to 1. This will be translated into x minus 1 as the first factor. Take our expression, x minus 5x squared minus 2x plus 24, substitute in 1 for x, do the math, and it equals 18. Does this mean that 1 is a factor? No, it does not, since it does not equal 0. Continue this process until you find the first factor. If we tried f at -1 and received the answer 20, we can rule it out. It is not a factor. F at 2 works out to be 8. Again, not a factor. F at -2, it works out to be 0. So -2 is also a factor. Since f at -2 is 0, f equal -2, the factor would be x plus 2 is equal to 0. We are now going to use this factor and long division to find our next factor. I'll go through this example on long division to find the next factor. So we determine by using long division, and we've covered this in our previous slideshow, it would factor to be x squared minus 7x plus 12. The next factor is x squared minus 7x plus 12. Now, factor the new quotient, x squared minus 7x plus 12. Since x squared minus 7x plus 12 is a quadratic function, you can use one of the rules we covered in our factoring and expanding video to factor the quadratic. The first two numbers must multiply to get 12 and add to get -7. Clues. Since 12 is positive, the two numbers have the same sign, which will be negative as the middle term is negative. So let's look at the factors of 12. -2 times -6 does add up to, or does multiply to get 12, but doesn't add to get -7. But wait, -3 times -4 is 12, and -3 plus -4 is 12. So the factors will be x minus 3 and x minus 4. Write our division statement. F at x then is equal to x plus 2 times x minus 3 times x minus 4. Now, let's put this all together. Take a look at an application for how we can use the remainder and factor theorem. Sketch a graph of the function y equal 4x to the exponent 4 plus 6x to the exponent 3 minus 6x squared minus 4x. Number 1, divide out any common factors in the polynomial. When we analyze the polynomial, we will see that every term has 2x as a common factor. So take this one out. Y equals 2x, and we'll be left with 2x cubed plus 3x squared minus 3x minus 2. Use the remainder theorem and the factor theorem to further factor this remaining cubic function. So we'll try 1, and when we substitute it in, we'll get the number 0. So 1 is a factor. X minus 1 is how we could write it. Application of the remainder and factor theorem. Use the quadratic formula to find the next two factors of 2x squared plus 5x plus 2. To use the quadratic formula, we have to identify the a value, b value, and c value. In our equation, we know that a is 2, b is 5, and c is 2. And here, we've substituted in to the quadratic formula. Minus b plus or minus 5 squared minus 4 times 2 times 2 divided by 2 times 2. -5 plus or minus the square root of 25 minus 16 divided by 4 will give us -5 plus or minus 3 divided by 4, and we'll come up with the two factors, x is equal to -1/2 and x is equal to -2. If you have forgotten the quadratic formula, just do a quick search to look for it. It is actually minus b plus or minus the square root of b squared minus 4ac all divided by 2a. So our factors now we know are 2x, x minus 1, 2x plus 1, and x plus 2. The zeros, therefore, are 0, 1, -1/2, and 2. Now, we want to use these zeros to sketch the graph. On an xy coordinate system, plot these points on our diagram. The equation is an even degree equation and the leading coefficient is positive. The graph will extend from second quadrant to first quadrant, looking at the charts we did in our previous slideshow. So the red dots equal the zeros or the x-intercepts, and we can see that we started in the second quadrant and we've ended up in the first quadrant. Your graph may not look exactly like this, but what I'm focused on when I'm marking is that it starts in the right quadrant, ends in the right quadrant, and the zeros are the correct values. Now, let's practice. Remember the remainder theorem and the factor theorem.